Okay, hello everybody. Welcome back. This is Unit 3, Day 10. Okay, we're talking about writing equations of parabolas using their roots. Okay, and so before we can discuss that, we need to talk about the definition of a conjugate. And so we've seen conjugates, but I'll give you the definition anyway, and then you can kind of interpret that for yourself. Okay, so some expression, okay, but with opposite side or connecting signs. Okay, what does that mean? What am I talking about here? Well, I'm talking about some DOTS here, some difference of two squares, right? Here's an example, okay, where we had x plus 2, x minus 2, right? These are conjugates of each other, all right, because they have, well, the same components except different connecting signs, right? Same thing with like something like this, 3x plus 1, 3x minus 1, right? Conjugate pairs, okay? So that's what that means, right? But leading into the next part, it says roots with radicals or imaginary numbers always come in conjugate pairs. So what does that mean, okay? Well, I'm sure I've probably emphasized it more than once. So when you take the square root of something, okay, you get a plus or minus version, okay? So when you're given a root, when it says one of our roots is negative square root 7, we have to assume that that other root is a positive square root 7. Okay. Same thing with imaginary numbers. Okay. Imaginary numbers come in conjugate pairs, right? So plus or minus 2i, or maybe it's 3 plus 2i, 3 minus 2i. Okay. Again, conjugate pairs. Okay. That's what that means. So whenever you're giving a root or an imaginary number, we have to assume that if they don't tell us the other conjugate pair, we have to assume that, okay? And we'll see those problems as we get down below. So let's try an easier one, right? So it says writing equations using roots. Reverse the solving process, okay? So let's talk about that. So write a quadratic equation whose roots are negative 3 and 7. So what is the sum of the roots, all right? When I add these together, I get a 4, okay? When I multiply these together, I get a negative 21. Okay, so you will see those numbers appear in just a few moments. All right, so let's work backwards. Okay, in your homework, there's examples of us working backwards, which we will go through those. But eventually, what I want you to do is I want you to use this process that I'm going to teach you, and it will save you a boatload of time. All right, but let's say, well, at this point you don't know it, so let's work backwards. All right, so it says x is equal to a negative 3 and x is equal to a 7. Okay, those are our answers. So let's keep working backwards. Well, x plus 3 is equal to 0 and x minus 7 is equal to 0. Right? Remember, when we're solving quadratics, right, when you get those two factors at the end, okay, we have to set them equal to 0. Okay, now we're going to take those two factors, okay, continuing to work backwards, and I'm going to, all right, multiply them together. Okay, and by doing so, I get x squared minus 7x plus 3x minus 21 is equal to 0. And then finally, and voila, and look what we see here. We see that 4, right, and we see that negative 21. Okay, so you're probably wondering, well, there's a negative in front of that 4. Okay, be patient. I will show you why there's a negative in front of that 4. Okay, but for now, just know that that 4 and that negative 21 appeared in our equation, right? And so the next problem says write a different quadratic equation with the same roots. Okay, so you're like, well, what the heck does that mean? Well, that's just any dilation. Okay, what do I mean by dilation? Well, dilations either increase the size of something or reduce the size of something. Okay, so I don't feel like multiplying by fractions, right? I don't want to reduce it, so I'm just going to multiply this equation by any number I feel like. All right, so I'm going to multiply it by a 3. Why not? And so by doing so, I get 3x squared minus 12x minus, what is that, 63 is equal to 0. Whoops, ran out of room. is equal to 0. Okay? So that is our new equation, right? So when it talks about write a different quadratic equation with the same roots, okay? If we were to solve this guy, right, well, we would first either take out a GCF or, you know, divide all these pieces by 3, okay? And so by doing so, you end up getting the same roots, okay? So it's just any dilation will work as far as coming up with a different quadratic equation with the same roots, okay? And by dilation, I mean just multiply it to increase the size of those numbers. Okay, so that's the long version of working backwards, all right? I want you to see the mechanics of what was going on here, but to save time, I'm going to teach you the shorter method of using sum and the product of roots, okay? So here's a nice little definition. It says the roots of ax squared plus bx plus c is equal to 0, with a not equal to 0. R1, R2 are the roots. Then the sum of the roots, okay, is negative b over a, and the product of the roots is c over a. Okay, more terminology here. All right, but basically, all right, what I'm looking for is this guy right here. Okay, this is the rule you want to remember. Okay, don't worry so much about what the sum of the roots is equal to and the product of the roots is equal to. Okay, I mean obviously find those out, but then just apply them to this guy right here, which is y is equal to x squared minus the sum of the roots times x plus the product of the roots. Okay, now below they have those things listed, that negative BA and that CA, okay, in the equation, all right? But let's talk about that, all right? So if we go up to the top here, remember our equation was x squared minus 4x minus 21 is equal to 0, okay? And so the sum of the roots, all right, so we have a negative 4 there, okay? So a negative, so let me write this down here. Y is equal to x squared minus, okay, a negative 4 over 1 times x plus negative 21 over 1. Okay, again, our b and c value are coming from this guy right here, and our a value in both cases is just a 1. Okay, so let's extend this out. We get y is equal to x squared minus, so two negatives in a row equals a plus, minus 21, and then finally y is equal to x squared minus 4x minus 21. Okay, so you can utilize this formula here, but this is home right here, guys. Okay, so anytime you find the sum of the roots, it's just x squared minus the sum of the roots times x plus the product of the roots. Okay, which as you can see up here, right, when we go back, right, the sum of the roots was 4, so x squared minus 4, and then the product of the roots was negative 21, so plus a negative 21 is just a negative 21. Okay. All right, so that's the basic rule here. All right, now let's put it into practice. Okay, so it says write an equation of a parabola whose roots are this guy right here. Now again, they were nice enough to let us know that these are conjugate pairs. Okay, but remember, if you got that radical there, okay, if they just put 3 plus 2 square root 5, we would have to assume that we also have 3 minus 2 square root 5. Okay, and so here's the fun part. All right, so we go sum. All right, we're just going to add these guys. 3 plus 2 square root 5 plus 3 minus 2 square root 5. And fortunately for us, what goes away? These guys right here. And we're left with 6. All right, and then the product is just 3 plus 2 square root 5. 3 minus 2 square root 5. Again, okay, this is kind of like our difference of two squares, right? So our first number is going to be 9, okay? Those middle terms are going to cancel, right? We would have 6, minus 6 square root 5 plus 6 square root 5, and then finally we'd get 2 times a negative 2, which is a negative 4, And remember, square root of 5 times the square root of 5 is just a 5. And so finally, our answer is 9. These guys get canceled. Minus 20, which is a negative 11. Okay? So that's our sum. That's our product. And then finally, all we got to do is take those two guys and put them into our formula up here. So y is equal to x squared minus the sum, which is 6x, plus the product, but in this case the product is negative, so minus 11. Let's take a look at example 3. I don't know why it says example 5 there. Another typo. Okay. So in this guy, all right, unfortunately, we have two fractions. Yay! All right, everybody loves adding and multiplying fractions. Well, I don't care so much for adding them, okay, but multiplying is pretty easy. All right. Unfortunately, though, I'm feeling kind of lazy, so I'm just going to type this into my calculator. All right. So if you guys are curious about this trick, all right, ask me in class. All right, but I go 3/4 plus a negative 12/5 in my calculator, and that gives me a negative 1.65. And then I hit the math frac. Okay, so I hit math frac, enter again, and I get negative 33/20. Okay, so that'll save you some time. All right, I'm comfortable with adding and subtracting fractions, but for the most part, okay, I'm not looking for that. I'm looking for the process here. I'm looking to get through this problem, okay? So if you need help adding and subtracting fractions, let me know, okay, because it's definitely important to know. But I'm not going to utilize it here. So I get negative 36/20. All right, I'm going to reduce that by a 4. So I'm going to get a negative 9/5. All right, and so now, using our process here, I'm going to go 0. Now you can leave it as y or 0, okay, whatever you prefer, all right. I see a lot of examples go back and forth, so I'm going to put this as 0, and you'll see why. I write it out like this. All right, so 0 is equal to x squared minus a negative 33/20 x plus a negative 9/5. And so I get 0 is equal to x squared plus 33/20x minus 9/5. Okay? Now, read below what's it say. It says equations must have integer coefficients. Okay? So as you can see here, all right, one of our coefficients is no good, right? That is definitely not an integer, okay? That is a rational number. However, integers are whole numbers. So this is how you take care of that, all right? So that's why I had this written as 0. So I'm going to rewrite this again. And then what I'm going to do is I'm going to multiply by the highest denominator, which in this case is a 20. And what does that do? It allows for me to cancel that 20 in the denominator. So I end up getting 0 is equal to 20 x squared plus 33 x minus 36. So let me pull this out here so you guys can see it better. Circle it here for you. Okay, and so that is our answer. All right, we cannot leave it like this. It has to be left like this. We have to have whole numbers for our coefficients. Okay? All right. So finally, last but not least, last problem here. So let's write a quadratic equation with a root of 6 plus 3i. Okay, remember, imaginary and radicals come in conjugate forms, so we also have to account for 6 minus 3i. Okay? So this is a particular problem where they didn't tell us the other conjugate. We have to know that rule. Okay? So anyway, there's our conjugate pairs. Let's add them together. So we get 6 plus 3i plus 6 minus 3i. So what gets added? Just the 12s. Those guys cancel. And then our product is going to be 6 plus 3i, 6 minus 3i. Again, difference of two squares problem, right? So I'm just going to go 36. I know those middle terms cancel, and then 3i squared, okay, is just going to be a negative 9i squared. Which again, I squared, if you recall, is equal to a negative 1. So we get 36 plus 9, which is equal to 45. And so our answer, which I will write in big old green letters, is going to be 0 is equal to x squared plus, oops, I'm sorry, not plus, hey-o, minus 12x plus 45. And there's our answer. Okie doke. So that is Unit 3, Day 10. Okay, hopefully that was pretty clear for you. And we will work on the homework problems in class. Okay, so good luck, you guys. And I'll talk to you in a little bit.